Aloha. So we have another problem that we wanted to take a look at, and I feel like this one is another one of those cases where, um, at initial glance, it is wrong. There's major inconsistencies, but when you really look into it, technically it's correct. Now, again, either this problem has a slight error, or it's being extremely sneaky um, and that wouldn't be consistent with how the worksheet was written. So I think that there might be an issue with this one. Anyway, here's what they're saying. If triangles are similar, find x. And in similar triangles, what you need to do is you always need to equate the angles. But we don't need to technically do that here because they are telling us that it's similar. But if they didn't tell us it was similar, what I would do is I would say, well, first thing you need to do is say whether or not the angles are the same. And you can do that if they gave you a piece of information and it really looks like the case in that PM is parallel to JK. That's exactly what it looks like. And so what you can say is even if PM weren't parallel to JK, you can always say that this angle is the same as that angle for sure. That's called opposite angles in geometry. Over here, this is where the PM being parallel to JK is important. You would need to say that this angle is the same as that angle, and that would be opposite interior angles. I believe that's what it's called. And then over here, again, you can say this angle is equivalent to that angle, and that's opposite interior angles. And then what you would say is you would say, okay, well, let's do this. What I always tell my students to do is whenever they're doing similar triangles or congruent triangles or whatever, always take the two triangles that you have and redraw them so that they're side by side and correctly oriented. And if they're correctly oriented in the way it should be, then let's see, let's rotate this 180. There we go. Then we would have something that looks like this, because the blue angle matches up with the blue angle, the red matches with the red, and the green matches with the green. And then you would say something like, okay, at this point, here's how we're going to do this problem is we would have to say 16 divided by 22 is equal to this thing divided by x. And so the thing is, you don't have enough information to solve this problem because those the given line segments are on the different sides. You can't do that. That's not really allowed. But again, we looked at this thing, and so my initial answer is that there is not enough information to solve this problem. But when I looked at this thing really closely, I said, all right, well, let's see if they define the angles correctly. They define the triangles. So we have triangle JK. I'm going to go through it very carefully. JK, so I'm going to put a line through JK, and they want to equate that to PM. So that would be this line, okay? And then the next one is KL. So I'm going to do a double line. And then the next one they said is ML. So there's your double line. And then the last one is LJ. So LJ would be my triple line. And LP, so here to here, would be my triple line. I'm just marking off the edges to try to make them consistent. And then what I'm going to do is I'm going to try to rotate this so that way they're oriented in the same way. And keep in mind that I'm ignoring these angles here. All right, so let's do this. Well, maybe I shouldn't ignore this angle in the middle, because this is the opposite interior angle, and this one is going to be true regardless of whether those are parallel. We're just assuming that these are straight line, and I think that is a safe assumption to make. That we're dealing with only straight lines here. Okay, so if I take this thing, put it right next to it, and then what I'm going to need to do is I don't want to rotate it, because if I rotate it, look, the triple line is on the right side, whereas the triple line is on the right side of, the left side over here. So I'm going to undo that. But what I'm going to do is I'm going to flip it vertically. There we go. So apparently, according to the definition, these triangles are what they're calling the similar triangles, which you can see that the picture is grossly drawn inaccurately, which is fine. I mean, it's teaching the students the lesson of never trust the picture. And then in that case, you can say, all right, well, we have 16 over 10 is equal to 22 over x. And then you have 16x is equal to 220, and then you divide by 16, and I don't have my calculator. Oh, there it is. All right, so we have 220 divided by 16 is 13.75. So technically speaking, this problem is correct, and it's written correctly, although the pictures is grossly skewed and not drawn accurately. And there could be a lot of confusion that students would have over this. I don't think that was the intention of the lesson. I think that honestly, if you folks, or if we just moved the 10 over to the other side, then this problem would be much more consistent and easy and understandable for students. Or if we move the 16 over to the other side, it would have been more consistent and easily understood by the students. And if you want to make a worksheet that teaches students to read the problem and not the picture, that's always a good thing, but make sure that that was what the original intention of the worksheet was designed for. So anyway, that's my thoughts.